Why is the Higgs boson so difficult to catch, to see?
There are 2 or 3 main components to this. One is that we didn't know where it would be, for one thing. It's difficult to produce well, and then decay, because we never see it as a whole particle. We only see what it decays into. So the most common thing is to produce a Higgs and have it decay to 2 B quarks. Okay? That happens very often in some sense. It's fairly common. The problem is there are so many other things that do that, we could never see it. Okay? So there are 2 big factors. One is that how it's produced is somewhat difficult and rare, and then for it to decay in ways that we can actually detect is rare again. So you have multiplying 2 rare effects. And it's heavy. And when you combine all those things, you need the LHC essentially to find it. We often use terminology that's not quite correct, okay? So we never really can say we see a Higgs boson. So it's a little bit more tricky. If we take one single event and we look at it, we don't know if it's a Higgs boson in that event. So what we look at is a statistical excess. We're looking for evidence that somewhere in a distribution of reconstructed masses, for example, that there's an excess somewhere. What we really see is not the boson itself, but what it decays into. Because the boson lives a very, very short time. So short that we can't even measure it, its life. But it will regularly decay in very special ways that are fairly simple, in fact. And from the decay products, which we can detect, for example, the Higgs can decay into 2 photons. We can measure their energies and momenta and then reconstruct the mass of the original particle. And that's how we say we see the Higgs. We see an accumulation of a bunch of events where there's a photon creating a mass at a specific value. To my knowledge, I can't imagine that we'll ever be able to see one. But there are many other particles like that. The top quark, bottom quark. You'll never see the top quark directly, only its decay products, because it lives about as long as the Higgs. Really tiny, almost 0 lifetime. But the bottom quark, okay, it lives about 1/1,000,000th of a second, okay, 10 to the minus 12 seconds. And believe it or not, we can detect that. So we can actually measure the lifetime of the bottom quark, because it's 1/1,000,000th of a second. So we can measure some pretty short times. But the top and the Higgs are much, much shorter than that.